Hey, welcome to my second session of parabolic functions. So the grade 11s, we are here again. I hope you learned a lot on the first activity, especially when a parabolic function is concerned. So now let me take this opportunity to welcome you again into this session where we are going to learn on sketching of the parabolic function. But first, if you really want to know how to sketch the parabolic functions, there are a few things that you need to take care of or you need to take into consideration. So now here we are given the equation of f of x, where it is negative x squared plus 2x plus 1. But now, what are these things that you need in order for you to be able to sketch the parabolic function? So here in order for us to be able to sketch our parabolic function, we are going to need the x-intercepts of f. That is the first thing. So we need to find the x-intercepts because this is where the graph will cut the Cartesian plane along the x-axis. And furthermore, we are going to need the values of our y-intercept. Okay, so we need the y-intercept. So the x-intercept, the y-intercept will help us to sketch the graph. And then one other thing that we also need are the coordinates of our turning point, the coordinates of the turning point. Okay, now these are the three most key things that we need in order for us to be able to sketch the parabolic function. But now I want us to highlight this, the turning point. So I mentioned in the previous lesson or the previous activity that when you work around the turning point, there is a formula that you need to use. Now, always remember that a turning point is actually our minimum or our maximum. I will highlight the minimum and the maximum once we are done sketching our parabolic function. So we need these three things in order for us to end up having a sketch. Okay, so now to begin with, let's go straight to our solution. So we are saying that to begin with, we must check the nature of our f of x. Here it says that the f of x is given by negative x squared plus 2x plus 1. Now, if you check, our value of a in this case is negative or is less than 0. Why do we say that the value of a in this case is less than 0? Is because we have the number starting or the equation starting with a negative. And if there is negative and you don't see any number here, it means that the number that should be here must be 1. So in other words, it means that at that stage, we have negative 1. And we know that once our a can be any number less than 0 or can be a negative, if a is negative, I hope you remember the shape of your graph. If a is less than 0 or if a is negative, it means that we expect our shape to be a set face. We expect our shape to be a set face. So we are going to have a set face. Now, So since we have something of this nature, now what else do we need to take into consideration is that once our A is negative, we must turn this negative into positive. So for you to say, I'm looking for the x-intercepts, x-intercepts, that is the first thing. So now we are on number A. On number A, we are looking for the x-intercepts. And we agreed that when you are looking for the x-intercept, always let y equals to 0. So now, in this case, it means that we are looking for the x-intercept, but we must make our y to be 0. And remember, I said f of x is actually y. Now, we're going to write this as negative x squared plus 2x plus 1 equals to 0. Now, in the previous activity, we factorized, but now I want us to use a quadratic formula. I want us to take this one and use it by means of a quadratic formula. So we are going to use a quadratic formula to find the x-intercepts. So we are going to use a quadratic formula. Now, what is this quadratic formula? Quadratic formula is given by x is equals to minus b plus minus plus minus we have our b squared minus 4ac all divided by 2a. So this is our quadratic formula. So we need to use this. But now let's check how much is our a, how much is our b, and how much is our c. So from this equation, our a is -1. From the very same equation, our b is +2. From the very same equation, our c is +1. So when we go and do our substitution into this equation, we will simply say that x is equals to minus this negative that I'm starting with is the negative of the formula. Then you open the brackets. Inside the brackets, you look where there is b. How much is b? We said b is +2. Then you write 2 plus minus, then from there you say again we have b squared. It means that we are going to say 2 squared minus 4 based on the formula. How much is the value of a? We said a is -1. Then you put -1 inside the bracket. And again, how much is your c? Your c is +1. Then you put your +1. Then everything that we have here is divided by 2 into -1. So now if you check here, it means that we have got plus and we also have minus. So this tells you that when we press the calculator at this stage, we are either going to put positive first or negative first. So it means that we will be able to solve the two values of x. So from here, you are going to press your calculator. So when you press your calculator, please start with the division sign. the button below ABS. So then you'll say negative, open bracket 2, then you put plus. Because your calculator does not have plus minus. So we first input plus, then you say the root, open brackets 2 squared, then minus 4 into negative 1, close bracket, open bracket again 1 and close bracket. Go at the part of the denominator, you press 2, open bracket, negative 1, close bracket, equals. Then you will realize that for the value of x, when you have used a positive sign, you get 1 minus root of 2. 1 minus root of 2. Or if you remove this positive and press it as negative, it means that you don't need to go back and retype this again. It means that the other value of x will be 1 plus root of 2. So these are the two x values that we need. So, but now, because the question says determine the x-intercept of f. So now let's check. These are the x values. Now we need to write this in the form of coordinates. These are the x-intercept, but we need to write them in the form of coordinates. Therefore, we say 1 minus root of 2 and 0. Why do we put 0? Because we said let y equals to 0. Then we close bracket. You open another bracket here. We say 1 plus root of 2 and 0. So the very same reasoning, we put 0 because we said let y equal to 0. Okay, once you're done with this, it means that you have identified the x-intercept. Now, the second question says determine the y-intercept. Determine the y-intercept. So when we determine the y-intercept, remember we said if you are looking for the y-intercept, you must let x equals to 0. So we must make our x to be 0. Now, if x is now 0, it means that from the original equation, we will say y is equals to minus, open bracket, 0 squared plus 2, open bracket, 0 plus 1. Then now our y is going to be positive 1. So if we write this in the form of coordinates, we will say 0 and 1. So now we know the x-intercept, we know the y-intercept. Now let's go and find the points, the turning point, the coordinates of the turning point. So number C, I'll bring it here so that when I do the sketch, I've got everything worked out. So here we're going to look for the turning point, or simply line of symmetry. So they can either say the symmetrical line or the turning point is exactly the same thing. Now, from there, if you recall from what we did in the previous activity, we said that every time when they say determine the coordinates of the turning point, you say that because you're given f of x equals to minus x squared plus 2x plus 1. So it means that you need the formula to determine the x value. That is the first thing. We need to determine the x value. And for us to determine the x value, we need the formula which says x equals to minus b over 2a. So now, from here, we are going to say our x is this equals to minus, how much is b? B is positive 2, open bracket, positive 2 over or divided by 2. How much is your a? A is negative, then for we put negative 1, then x is equals to 1. Now, this is the x value. This is the x value of our turning point. Now, after finding the x value of the turning point, we go and find the y value. So we need the y value of the turning point, and therefore our y value will be calculated as such. Therefore, on finding the y value, take note, we said that we substitute x equals to 1 into f of x. So we're going to take our f of x, then we substitute that with 1. Then it means that we have got y is equals to minus 1 bracket squared plus 2 into 1 plus 1. So when you press the calculator, you will get that your answer says 2. So it means that y is equals to 2. Because they wanted the coordinates, it means that we would write the coordinates of the turning point. The coordinates of the turning point. Therefore, our turning point will have the coordinates 1 and 2. So we have now finished finding the x-intercept, the y-intercept, the coordinates of the turning point, and now the fourth question, question number D. It says, sketch the graph. Sketch the graph. So now we are going to sketch our graph. So when we sketch the graph, we need a Cartesian plane. We need a Cartesian plane. We need a Cartesian plane. And then this is our Cartesian plane. So don't worry with the skewness of the line, they will eventually work themselves out. Now, so what is the advice here? The advice is that every time when you draw a graph, you must always make measurements. You must always make measurements. And your measurements throughout, they must be constant. They must be constant. So this means that I'm going to put my ruler at 4. And then I will start to make the readings. So here I've got, so with this one I will have now, and then here I will have that, and then this side I will have this, and that I will have a value there. And then when I come to this side, I will have that, I will have this, I'll have this, I'll have that, and the other one will sometimes be there. So now it means that if I can make readings to this, I can simply say that I've got 1, 2, 3, 4. And then this side I've got -1, -2, -3, -4. So both sides are equal. So now if I turn my ruler to be vertical, it means that we will have something of this nature. Let me try to move this here. Still again, we were at 4. Then I'll have 1, 2, 3. And this side I'll have 1, 2, 3. So literally it means that based on this sketch, this is 1, 2, 3. -1, -2, -3. So now, if I go and do my readings, so now let's check. We can start with the turning point. The turning point is 1 and 2. So we need a line that will connect the two things, 1 and 2. So 1 and 2, let's take 1 and 2. So the value of x is 1. Therefore, it means that we are going to have something of this nature. We will have something like this. I'm trying to draw dotted lines so that we can represent this as the line of symmetry. So that this is how it will be. But this line is the line that passes through 1, and it must connect with the line this side. It must connect with the line this side. So it means that our turning point will be somewhere there. Let's indicate it by a red color. So this one will be our turning point. Now they said that if that is the case, how much is our y-intercept? Our y-intercept is 0 and 1, therefore we need 1. 1 will be somewhere there. And then from there, when you press or when you calculated the x-intercept, the first one was 1 minus root of 2. And 1 minus root of 2 is the same as x is equals to negative 0, 4. 0, 4 is nearly half of this side. So it means that our graph will pass somewhere there. And when we do that, it means that this side is going to be 1 plus root of 2 is 2, 4. And 2, 4 can be something somewhere there. So when we draw, we are going to start with the turning point. So we will start with the turning point and then connect one arm this side. Sorry for the skewness. I got disturbed in my hand, but I will erase this part. Okay, we can start it from here. Let's remove everything. Okay, let's remove everything. Then we said that we'll have our point somewhere there. Okay, for now, let's remove this line. Now, if we start with the turning point, it means that our graph will be something like this. And then this side, it will pass through here and goes there. It will pass through here and goes here. So meaning that once it arrives there, it will extend to that direction. So every time, once you are done drawing the graph, please put the arrows at the end of the two arms. I'll explain why. So now this means that this is our first x-intercept, this is our second x-intercept. So this one is our y-intercept, this is our turning point. So it means that this is the answer for number A, answer for number A, answer for number B, answer for number C. So if you go back and check, you'll notice that C, the question C, was about the turning point. Question B was about the y-intercept, and question A was about the x-intercept. So all the values that we have, they are displayed there. So you go and check how much was the answer for question number C, which was the turning point is 1 and 2. Then for B, it was 0 and 1. For number A, we had negative 0,4 and 0. Again, we had 2,4 and 0. So this is our graph, and therefore we need to highlight something before we can stop with this. Now, one other questions that they normally ask on number E, they say write down the domain of F. Write down the domain of F. So when they say write down the domain of F, it means that we are going to check which, remember that domain are all the X values where the graph exists. So in terms of a parabolic function, so it means that for a domain, we will have X is an element of real numbers. This is what you write for domain. Or you can simply say X is an element from negative infinity until positive infinity. So let me use the correct bracket. So from the negative infinity until positive infinity. And then again, if they can ask you about, they say, write down the range of F. And you must know that a range is Y values where the graph exists. So now, in terms of our graph, now we are checking or in a graph always when you write a domain, a range, you start from the negative Y values. Negative Y, you start from this line going up. We move from negative going up. So, pro lebelela, or our graph arrow so, or our di. Therefore, it means that if the range of A less than 0, graph so it means that we are going to say the answer for this is that Y is an element from negative infinity until y of the turning point. If a is less than 0, this is your range. But if a is greater than 0, I'm just giving you this as tips. So now we are going to check y is an element of negative infinity until y of the turning point. What is the y for turning point? We found that the y for turning point is 2. Then you put a square bracket to show that tomorrow cut more. But if a is greater than 0, graph and the range will be y is an element. You start by this. It's the opposite of the other one. You nyaga the y of the turning point until positive infinity. Then it goes like this. So this is how you determine the range and the domain of the parabolic function. Okay, with this, I would like to appreciate your time for listening, and please let's practice more of this and then see how far we can get. For now, keep up with the good work, and we will meet again in the next session.